Welcome to Brunswick's GS Series Pin Setter Operation and Service Training Program. This series is designed to prepare you for the service, repair, and maintenance for the full line of GS Series pin setters, including the GS 92, 96, and 98. Various versions of the GS pin setter will be shown throughout these video programs. This is the first of a 4-program series which corresponds to the written manual for easy referencing. This tape will cover pin setter basics, an overview of the mechanical sub-assemblies and pin setter cycles. Program number 2 covers switches, solenoids, electronic assemblies, diagnostics, and troubleshooting. Program number 3 contains short explanations of the adjustments on GS Series pin setters. Program number 4, which completes this series, will cover preventive maintenance. 7 mechanical subassemblies and various electronic subassemblies make up GS Series pin setters. The ball pit, the ball accelerator, the pin elevator, the distributor, the setting table, the sweep wagon, and the drive frame. Whenever any position or motion is described in this tape or in the manual, it will be described as if you were a bowler looking at the pin setter from the foul line. All references of clockwise, counterclockwise, right, left, forward, or rearward will originate from this viewpoint. Before getting into the details of the subassemblies, we need to cover a few very important safety instructions. Pin setter maintenance should only be performed by properly trained personnel. Only correct tools should be used for the job and must be removed before turning the machine back on. Always wear proper clothing and non-slip shoes while working on the pin setter. Toxic or poisonous cleaners should never be used. Always have fire extinguishers available and store oily rags in a fireproof container. Care should always be taken while you are in front of the pin setter so you don't accidentally trigger the photocell that lowers the sweep. Before doing any work, the power must be turned off first. On pin setters with a universal electronic system, turn the high voltage box switch to the off position. If more than one person is working on the pin setter, turn both the front and rear high voltage switches off. If you are working on both pin setters of a lane pair with universal electronics, always turn off the power at the universal common box and remove the cable from the common box. On pin setters with a consolidated electronic system, turn the stop-run switch to the stop position. If more than one person is working on the pin setter, turn both the front and rear high voltage switches off. If you are working on both pin setters with consolidated electronics, always turn off the main power at the consolidated high voltage box and disconnect the incoming 3-phase power. Always lower the sweep board when you're working on the pin setter or the ball accelerator. Use a jack stand or other suitable support when you're working under the setting table. Always remember to reinstall all the machine guards and the ladder after your work is completed. All persons should be clear of the machine before restarting. Now that we've covered safety, we will review the 7 mechanical subassemblies. Starting with the ball pit area, you'll find a ball cushion assembly that absorbs the impact when struck by a bowling ball. The heavy rubber pit curtain, which stops the rearward movement of the pins and allows them to fall onto the transport band. And finally, the transport band assembly, which consists of a large band moving on 2 rollers. It pulls the pins and ball rearward. There is a hydraulic shock absorber mounted to the frame assembly that helps absorb ball and pin impact. After impact, the cushion returns to its full forward position, guiding the ball into the ball accelerator. The ball accelerator is mounted between the 2 pin setters. It returns balls to the bowler from either lane. It's powered by a three-phase motor connected to the universal common box or consolidated high voltage box. Entering from the transport band, the ball goes through a door and onto a track. A large, flat belt mounted on two driving drums propel the ball forward to the ball lift. The ball accelerator's door system has been designed to prevent two balls from entering at the same time. It will not allow pins to enter the ball door. The pin elevator receives pins from the transport band and then raises them up to the distributor in preparation for setting them on the lane. The elevator is equipped with 14 shovels that lift one pin per shovel. The shovels are moved by two parallel chains, which are belt-driven by the distributor motor. There are two pin feed deflectors at the bottom of the elevator that help the transport band guide the pins into the elevator. If a shovel picks up more than one pin, these deflectors will help knock the extra pin off while positioning the remaining pin in the middle of the shovel. Halfway up the right side of the elevator frame is an ejector that will wiggle each shovel to remove one of two pins on the same shovel. When the shovel nears the top of the elevator, the guide on the right side tips the shovel to allow the pin to roll out onto the pin guide wedges. The two pin guide wedges turn each pin so that they always go onto the round belt's bottom first. On GS92 pin setters, the round belts carry the pins over a pin guide wire. This wire switches the pin guide over, so the next pin is sent to the opposite center lane. On GS96 and later pin setters, as pins enter the shark switch, they contact the pin count switch mounted on the top of the elevator. The switch counts each pin as it rolls out of the pin shovel and lands on the pin guide wedges of the shark switch assembly. The switch information is used to determine which distributor lane the pin should enter to find an empty pin station. The shark fin is controlled by a red solenoid which, when energized, directs the pins into the appropriate distributor lane. It uses the pin count switch information to make its decision on which lane the pin is sent to. This feature reduces overflowing pins and speeds up the pin setter cycle time. The pin moves down the distributor lanes until it finds an empty pin station. There, the pin falls onto the pin station's retaining bow. This unlocks the ejector flap and allows any other pins to move onto the next available station. When the setting table is ready to receive the pin, the retaining bow will drop the pin as the pin holder's gripper engages the pin release lever. Any pins that do not find an empty pin station will return to the transport band through the overflow chute located at the end of each outside distributor lane. The pins are then recycled back through the elevator system. If no bowling activity occurs within 45 seconds, the system automatically shuts off the distributor motor. This saves energy and reduces unnecessary wear and tear on the pin setter. The setting table detects for standing pins after a ball has been rolled. It closes the spotting tongs to pick up any pins standing on the lane, or loads the pins from the distributor to set them on the lane for a new frame. It has 10 pin holders mounted on 4 swing shafts. They are latched into the horizontal position when the table is up loading pins and waiting for a ball, down detecting pins, or closing the spotting tongs. When the table goes all the way down, all 10 pin holders are rotated to a vertical position to set the new pins onto the lane surface. The pin holders have a pin detector plate on the bottom that is pushed upward by the top of a pin when the table is lowered during detection. The electronic system uses this information to determine what the pin setter must do next. A pair of pin grippers, which are solenoid controlled, will open during pin loading time and again when the table is downsetting pins on the lane. On GS96 and later pin setters, the 7 and 10 pin grippers will open to double load these positions. This feature reduces the cycle time and increases the efficiency of the pin setter. Over on the left side of the table is a square shaft and latch assembly. This latch is used to keep the pin holders horizontal when the pin holder is not up in the home position. When the table goes all the way down setting the new pins, the square shaft will be rotated by a stroke limiter solenoid, which releases the swing shaft latch. A large spring mounted on the front swing shaft then pulls the pin holders to their vertical position. After the pins have been set, a roller on the rear shaft will press against a table jam switch actuator arm. This overpowers the spring on the front swing shaft and rotates the pin holders back to their horizontal position. They will stay horizontal until the stroke limiter solenoid is energized again. Another square shaft, located on the right side of the table, uses a series of gears and tooth bracks to drive all 10 sets of spotting tongs closed, as the pins are being raised to clear deadwood from the lane. The shaft then turns the opposite direction to reopen the tongs, leaving the pins on the lane for the next ball. Located on each side of the setting table are table rack tubes. On the right-hand side, the tube has a chain that goes up and over a sprocket. The sprocket is mounted on the guide tower and connects to a crank arm bolted onto the main table shaft. The table motor uses these to raise and lower the table. The left-hand table rack tube has a T-stop on the top of it, which stops the setting table from being lowered when it comes in contact with a stroke limiter plate. This allows the setting table to be lowered only part way for detecting and respotting pins. The stroke limiter solenoid then pulls the plate out of the path of the T-stop when the table is lowered to set new pins. The two functions of the sweep wagon are to prevent pins from rolling forward and to clear the lane of unwanted pins. The sweep wagon is held up by the sweep release assembly, which uses a solenoid to force the swing lever rearward. A roller bearing on the bottom of the swing lever pulls away from the tipper control, dropping the sweep wagon. The lowering of the sweep is controlled by an attenuator and a hydraulic shock absorber. When the sweep is down, the motor turns the sweep shaft clockwise. This rotates the crank arms and turnbuckles to drive the shaft and arms rearward and forward. To keep the operation smooth, there are 3 guide rollers on each side of the assembly. When the sweep is fully forward, the sweep motor is shut off and its internal brake holds the sweep in this position. The drive frame assembly consists of 3 motors. The front motor operates the distributor, transport band, and the elevator. The center motor runs the sweep, and the rear motor raises and lowers the table. Now, we will look at how GS Series pin setters respond to bowling activity, which is referred to as cycles. To begin a cycle, the following sequence of events must occur. The pin setter must be on and waiting for a ball. The ball detector sees a ball and sends a pulse to the pin setter CPU. The pin setter CPU must have a confirmation that the following conditions are in effect. The table is up, the sweep is up and forward, and the spotting tongs are fully open. The ball door solenoid locks the ball door for 3 seconds to prevent pins from entering the accelerator. The sweep release solenoid energizes to drop the sweep. The sweep wagon lowers completely to the guarding position. The table motor runs counterclockwise to start the cycle. A cycle is divided into 3 segments. First is the detection stroke, where the table is lowered to determine which pins have been knocked down. Next, the table is raised and the sweep clears the deadwood. And finally, the pin setter prepares for the next ball. There are 5 different first ball cycles and 3 second ball cycles that the pin setter can perform. Starting with the first ball cycles. During a strike cycle, the pin setter detects that all the pins were knocked down, sweeps away the deadwood, and sets 10 new pins. During a standing pin cycle, the pin setter picks up any pins left standing on the lane, clears the dead wood, and then sets them back down on the lane and waits for the second ball cycle. A short cycle will occur when the 7 or 10 pin was the only one knocked down, or a gutter ball was thrown. The pin setter will skip the sweep portion on the cycle to save time. It then waits for the second ball. An out-of-range cycle happens when a pin is pushed off of its normal position, but does not fall. It will not allow the table to lower to its normal detection height. When this occurs, the pin setter will stop and signal for the technician to remove any deadwood and restart the pin setter. When a first ball foul is detected by the beam on the foul line, the pin setter CPU ignores any pinfall, sweeps the deadwood, and sets 10 new pins for the second ball. There are 3 second ball cycles. During the second ball cycle, the GS pin setter has the capability to generate scoring information internally or use an external scoring device. If using an external scoring device, the pin setter will use a single detect cycle, which stops the setting table from being lowered. It will then sweep and set 10 new pins to get ready for the next bowler. The pin setter will use a double detect cycle when it provides its own pinfall information. For scoring on Bowler Vision, AS90, ASK, or Framework's automatic scorers. In this cycle, the table lowers to detect. The sweep clears the pins, and then 10 new pins are set. A second ball out of range occurs when a pin has been moved off spot. This cycle is only active on pin setters that are configured to use the double detect feature. The pin setter must be reset by the mechanic or technician. It will then sweep and set 10 new pins to get ready for the next bowler. This completes this tape and the first part of your training. Please use your manual to review any operations that were unclear. The second part of your training is on program number 2. It contains information you will need to know about the electrical and electronic aspects of GS series pin setters.